Welcome to class, everyone. Go ahead, grab your safety goggles, and throw on those lab coats for today's explainer, because we've got a genuine chemical mystery on our hands. Have you ever wondered how scientists actually figure out what a substance is, even when it looks like plain old water or, say, completely invisible ink? Well, today we're becoming scientific detectives to reveal the invisible. Here's a quick look at our detective toolkit for today's investigation. We'll start with the magic mystery, then move on to brewing red rose indicators, check out the golden turmeric test, dive into invisible clues with scent tests, and finally, case closed, mystery solved. Let's get right into it. All right, section 1, the magic message mystery, revealing the invisible. So picture this. You walk into a science fair, right? And you see a completely blank piece of paper. Suddenly reveal the words, "Welcome to the wonderful world of science." The second a volunteer lightly missed it with a mystery liquid. Now, as curious scientific detectives, we have to ask ourselves, how exactly do we reveal the invisible? Like, how does a supposedly invisible message just burst into vibrant color just by getting wet? Magic? No way. It's chemistry. And to get to the bottom of this, we really need to understand the hidden nature of everyday substances. To solve this, we're not just going to sit here reading textbooks. We're setting up our very own hands-on testing stations, exactly like these diligent students, to figure out how different substances react to each other. We need to find out exactly which substances are acidic, which are basic, and which are neutral. And to pull that off, well, we need to create an indicator. Which brings us to section 2, brewing red rose indicators, our first clue. Our very first investigative tool is going to be extracted straight from fallen red rose petals. Yep, you don't even need to pluck fresh flowers for this. Petals that have already fallen to the ground work absolutely perfectly for our lab. Prepping this red rose indicator is actually remarkably simple. First, we just take a fistful of washed red rose petals and crush them thoroughly using a mortar and pestle. Next, we pop them into a glass tumbler and pour in some hot water, just making sure the petals are totally immersed. Then cover it with a lid, let it steep for about 5 to 10 minutes until the water takes on this rich, deep color. And finally, we filter it. That colored liquid left behind, that's our highly effective flower extract. Okay, pause right here, class, because we have a crucial safety protocol to talk about. Because this extraction requires hot water to properly steep the petals, you must, absolutely must, perform this step under the direct supervision of an adult. Safety is the foundation of all good science, right? Let's not forget that. So, the really cool part is how this beautiful liquid actually behaves once we're in the lab. Once it's brewed, our rose extract becomes a brilliant acid-base indicator. Basically, if you drop it into an unknown substance and it magically turns red, boom, you know you found an acidic solution. If it turns a vibrant green, you've got yourself a basic solution. And if nothing happens, no color change at all, well, then the substance is neutral. It is literally like having a chemical compass. Moving on to section 3, the golden turmeric test, uncovering bases. Digging a little deeper into our investigation here, let's check out another tool. We don't just have to rely on flowers from the garden. Let's raid the kitchen. We're talking about a common spice rack staple that doubles as a brilliant chemical detector, turmeric. Making our own turmeric testing paper is incredibly straightforward. We simply take a spoonful of turmeric powder, mix it with a little water, and create a golden paste. Then carefully coat a piece of filter paper in that paste until it's completely brightly yellow. Let it dry, and then just snip that yellow paper into thin, testable strips. And just like our last experiment, safety is our absolute top priority in this explainer. I know turmeric is just a common household spice, but the process of handling lab materials, drying them, and cutting filter paper means you still need to keep an adult nearby when you're prepping. Let's see how this builds out our toolkit. When we map out the actual results, we find out that these golden turmeric strips are incredible at sniffing out basic substances. You see, when a drop of a basic solution hits the paper, it dramatically changes color to a deep red or brown. But if the solution is acidic or neutral, the paper stays its original yellow. So, while it is a fantastic detector for bases, it kind of falls short on telling the difference between acidic and neutral stuff. You know what's really fascinating, though? This golden spice isn't just a handy indicator for a chemistry lab. Actually, turmeric is a member of the ginger family, and it's heavily utilized in the Ayurvedic system of medicine. Beyond just adding great taste and a pop of color to food, it's considered to have incredible health benefits and is commonly used in traditional home remedies. It's just a really wonderful example of science and tradition overlapping. Up next is Section 4, Invisible Clues, Scent Tests. So far, we've been relying entirely on our eyes. But hey, sometimes in a good mystery, the clues aren't visual at all. We're going to expand our toolkit now by using what scientists actually call olfactory indicators. These are highly specific substances that physically change how they smell depending on whether they're interacting with an acid or a base. It's just a completely different, almost invisible way to reveal the nature of the chemicals around us. So for Activity 2.6, to set this experiment up, we're going to use something with a very strong, distinct smell, finely chopped onions. We seal these pungent onions in a container overnight, along with a few clean strips of cotton cloth. By the next morning, those cloth strips have completely soaked up the onion's strong odor. Next, we test those stinky strips by applying some mystery drops. We'll put tamarind water on one strip and a baking soda solution on another. And this completely illustrates the power of a scent test. When we apply that tamarind water, which is an acid by the way, the strong, pungent smell of the onion remains entirely unchanged. You can still smell it, plain as day. But when we apply the baking soda solution, our base, the characteristic scent of the onion is just completely altered, basically neutralized. So even without seeing a single color change, our noses have successfully identified the basic solution. How cool is that? Finally, Section 5, Case Closed, Mystery Solved. All right, class, let's wrap this up. We've explored visual indicators using red rose petals and turmeric, and we've explored olfactory indicators using onions. Now, by understanding how these indicators react to acids and bases, the big secret of the invisible ink from the science fair is finally revealed. You see, someone used an acidic substance, probably orange juice or lemon juice, as their ink. When they applied it to white paper and let it dry, it became totally invisible. But because we know that spraying an indicator reveals hidden chemical properties, we know exactly what happened. When that volunteer sprayed our carefully brewed red rose extract over the paper, the acidic juice writing instantly reacted with the indicator, turning the hidden letters a brilliant, bright red. It wasn't magic, it was just chemistry at work. So, my fellow detectives, you successfully learned how to uncover the hidden properties of the world right around you. But remember, science is an ongoing journey of questions. So I'm going to leave you with a final, provocative brain teaser for your next lab session. We know that grape juice is an acid, and mixing it with our red rose extract gives it a nice tint of red color. But what spectacular chemical reaction do you think will happen if you drop some basic baking soda right into that red acidic mixture? Think about how the indicator is going to respond. Keep questioning, keep experimenting, and I'll see you in the next experiment.